In this video, we're going to look at an example of finding the unit tangent, unit normal, and binormal vectors. So it asks us to find those three vectors for the curve r of t equals cosine t, sine t, log cosine t at the point 1, 0, 0. So the first thing we need to do before we get down to any of those things is take the derivative. The derivative of our vector-valued function in this case is negative sine t, cosine t, negative tangent t. The unit tangent vector is 1 over the magnitude of the derivative times the derivative. Well, the magnitude of the derivative will be the square root of sine squared plus cosine squared plus tangent squared. Sine squared plus cosine squared gives you 1. 1 plus tangent squared gives you secant squared. Square root of secant squared gives you, well, absolute value of secant. However, we're interested for these particular vectors at the point 1, 0, 0. We recognize that when we plug in 0 for t, we get the desired point. The secant will be positive at that point, so we need to worry about the absolute value bars as they pertain to this particular problem. Running the 1 over secant t through, we get negative sine t cosine t, a cosine squared t, and a negative sine t. Now we need to differentiate that in order to be able to get the unit normal vector. Well, the first thing we notice here is that sine t cosine t can be written as 1/2 sine 2t. So the derivative of that will be just a cosine 2t. So that's where the negative cosine 2t comes from. When we differentiate cosine squared t, we'll get a 2 cosine t times a negative sine t by the chain rule. But again, 2 sine t cosine t is the same thing as sine of 2t. So we get a negative sine 2t in the denominator, or excuse me, in the second component. The third component is a straightforward negative cosine t. To find the unit normal vector, we need to do 1 over the magnitude of the derivative of t times the derivative of t. In the denominator here, we'll get cosine squared of 2t plus sine squared of 2t. That adds up to 1, so we get 1 over square root of 1 plus cosine squared t, and then times our derivative of the tangent function. We're asked to find these values at the point 1, 0, 0. So before we do the binormal vector, let's go ahead and plug in what we get for the tangent vector at 0 and the normal vector at 0. Putting in 0 for t here for the unit tangent vector. Well, sine of t is 0, so we get 0 for the first component. Cosine of t is 0 is 1, so we get 1 here and 0 here. For the unit normal vector, when we put in 0 for t, we'll get 1 over root 2 here. This will be negative 1, this will be 0, and this will be negative 1. So now we're ready to take our cross product. We can pull the 1 over root 2 out in front, do the cross product of the 0, 1, 0, and the negative 1, 0, negative 1. And we'll end up with the vector 1 over root 2 times negative I plus k is the binormal vector.